Okay, so today we're going to talk about earthquakes. So first off, remember, pause and rewind whenever you need to. Write down all highlighted vocabulary. Make sure you read it all. There's quite a bit this time. Look out for test question alerts. And please make sure you're writing your notes in your notebook or you're typing them. I no longer want you to use the printed slides on the screencast quiz. So first of all, what are seismic waves? Well, an earthquake is the shaking and trembling that results from the movement of rock beneath the Earth's surface. Earthquakes are caused by plate movements. We talked about that in class, so when enough stress builds up, eventually the rock moves, and you get an earthquake. Energy from this earthquake travels in the form of what's called a seismic wave. And a seismic wave are vibrations that are similar to sound waves. So the speed and path of the waves depends on the material through which the waves travel. So we talked about this in class a little bit when we did our theoretician and geologist little mini lab. So seismic waves are going to travel quicker through solid and slower through liquid. Same thing with when you're in a pool and you're trying to talk to your friend and you're underwater. It's muffled and it takes a little bit longer to get to the other person. That's why it's harder to understand. So, like when you throw a rock in a pond, seismic waves travel out from a center point, and that center point is called the focus. The focus is the area beneath the surface where the rock begins to break or move, so where that center point is, and where the waves are traveling out from. The epicenter is the spot on the Earth's surface which is above that spot, so above where that break or move is. And there are three types of seismic waves. The fastest type is a P wave, and these compress and expand like an accordion. The S wave is the second fastest wave, and that vibrates from side to side. And then we have surface waves. Seismic waves that are surface waves travel similar to how a wave moves in water. And these are usually the ones that are damaging or cause the damage. We measure earthquakes by using a seismograph. And the seismograph is an instrument that records and measures an earthquake's seismic waves. And there are two scales that I want you to know. The first one is the Mercalli scale, and that measures the amount of shaking of an earthquake. That's done basically through observation, and it's done basically by observing the damage the earthquake caused. So did buildings fall down? Did rails bend? Is there nothing left? The second type is the Richter scale, and that measures the magnitude or the size of the earthquake. So magnitude is how big was the earthquake. And here's a picture of the Richter scale, and I just want you to write down and remember that each level on the Richter scale is 10 times stronger than the previous level. So if we have an earthquake that's a 3, it's 10 times stronger than an earthquake that was a 2. And if an earthquake's a 9, it's 10 times stronger than an earthquake that's registered as an 8. If you have an earthquake that's a 5, it is 1,000 times stronger than something that's a 2. The second one is the Mercalli scale, and that's basically damage. So if you have a Mercalli that's a 4, you can have a vibration that sounds like the passing of a truck on the highway. It kind of vibrates. You can kind of feel it. If it's a 6, you definitely will feel it. It's going to move your furniture and it's going to crack your walls. If you have an 11, traffic rails will bend greatly and pipelines are going to get damaged. If you have a 10, many buildings and bridges get destroyed. So you can tell that the Mercalli scale is based on damage. Richter scale is based on how big the earthquake is and how the movement, the shaking is. How do we locate an epicenter? Well, we locate an epicenter using what were called seismograph stations. So they use the seismic waves to locate an epicenter. And I want you to remember that P and S waves travel at different speeds. And scientists track when these waves reach the certain stations, and they draw circles on the map based on this data. The more time it takes, the further away the epicenter is. And here's what that looks like as my thing pops up. So Portland has this circle. Salt Lake City has this circle. So this is where people who call in and the seismic waves reach. So that's the range of the seismic wave. And Los Angeles is here. So we take those three circles and we find where they intersect. And we find the epicenter. And that's all I have.